Okay, this is number 9 in section 5.4 and very similar to, let's see, number 10 and also I think I did number 2. Okay, so let's use the eigenvalue method to find the solution to this matrix form, right? This is really, I mean, there's a matrix in here, right? We have our A, our coefficient matrix, times our column vector. So we know, right, our coefficient matrix is, it's a 2 by 2. It's 2, -5, 4, -2, and we want to find a particular solution, right, in this case, because we have initial conditions, and obviously we have to find the general solution first and then use our initial conditions to find the particular solution. Okay, so similarly to the last few examples that hopefully made sense. Okay, let's find let's use the characteristic equation. And our characteristic equation is basically the determinant, right, of A minus lambda I. Right, these are not absolute value symbols. It means determinant, or if you prefer to use DET of this guy. And that's, okay, going to be equal to 0. And, well, let's go ahead and substitute some values here. So we have, okay, so we have, let's do this neatly. So we have, let's be consistent here. So 2, -5, 4, -2. And then I'm going to go ahead and write plus, right? And I mean, this guy here, well, again, let's just write in the steps. Okay, so we have minus lambda here. And this is a 2 by 2, so it's an identity matrix. Right, so 1's on the diagonal, and that, again, is determinant. And again, this is just matrix operations, a little bit from 5.3. And so we have the determinant of, so we have our coefficient matrix that I'm just rewriting. And I'm going to go ahead and write plus, because when I use scalar multiplication, right, this lambda is basically going to be multiplied to each entry. So we have, it basically becomes negative lambda, right, and zeros. Okay, and then a little bit of just matrix addition, right? Add each component, right, depending what entry you're in, right? So this guy plus this guy plus this guy, and so forth. So we have 2 plus negative lambda, which is just 2 minus lambda. -5 plus 0 is the same thing. We have 4 and -2 minus lambda. Okay, so now let's find the determinant of this matrix, which is a very nice 2 by 2 matrix. So we have, right, the product of those guys minus the product of these guys. So let's write 2 minus lambda times minus 2 minus lambda, and it's minus 4 times -5, which is going to be minus 20, so it's really plus 20. So equals 0. And well, let's just go ahead and FOIL this out. -4, well, let's just do all the work, might as well. -4 minus 2 lambda plus 2 lambda plus lambda squared plus 20. And, oh, this is nice. That's gone. And, ooh, this is very nice. So I get lambda squared, and then I get my 20 minus 4, so that's 16. So if we solve for lambda, right, that's the goal. I mean, it's our eigenvalue, or it's really the root of our characteristic equation. So we have lambda squared equals -16. I'm going to use the square root property. So plus or minus the square root of -16. And we know this is really 4i, right? And it's, I mean, 4i and -4i, because remember, complex numbers come in, they have a conjugate pair. So I don't know, let's just call lambda 1 4i, and lambda 2 negative 4i. If you want to call lambda 1 negative 4i, and that's fine. And remember, this is really, again, 0 plus 4i, 0 minus 4i, right? We have our complex numbers, a plus bi form. Okay, so we found our eigenvalues. So eigenvalues. So now we know that there is an associated eigenvector to each eigenvalue. So let's go ahead and find that. And, well, actually, I'm going to go ahead and stop here. I'm about 5 minutes. I think it's just quicker to upload. So I will do the eigenvectors and the rest of the problem in the next video.